Hello, everyone. Welcome to day 2 of Industrial Ethernet Week. We're so excited to have you with us today. I'm excited for today. This is all about how we make Industrial Ethernet as easy for the customer as possible. We have a great panel ahead of us and several products to cover, and even a configurator to talk about how to make things easier when it comes to ordering product. But first, before we jump in, I wanted to recap yesterday a little bit. If you weren't able to join us, we spent time talking about sustainability and what that really means for us. What is sustainability? How is it defined in terms of scope 1, 2, and 3 emissions, and where do the most emissions come from, and what can we do about it? We spent time just going through localization of supply chain and how much of an impact that can make on our carbon footprint. And we did talk about sustainability as a differentiator. We said, look, in the history of the Industrial Revolution, it's always come down to price, lead time, and quality, and when it comes to a customer making a decision about a product. But it appears that the new wave that we'll be going through in the next decade, 2 decades, 3 decades, will also include sustainability. And companies that are on the forefront of this and being able to understand their carbon footprint and communicate it to their customers will be at an advantage. I encourage you, if you haven't seen this, to go back and watch it. We also talked with Beyond Design, an engineering design firm, about how they incorporate sustainability in their designs and how much of the carbon footprint you're going to be, so much of your carbon footprint is included at the very front in both the design of the product and the packaging. So a very exciting conversation. And again, if you didn't get a chance to join us yesterday, please go back and watch it. But today is all about the ecosystem, the components, the systems, and the solutions that make Industrial Ethernet as simple as possible for the customer. We have a panel today. We have Bill Martin from Rockwell Automation and Frank Moritz from SICK to talk about how we are working together collaboratively in an ecosystem to simplify the design and the installation for customers. And we'll also be talking about some of the products and the solutions to make it easy. But I think we all know that not only does it have to be easy to install, but it also has to be easy to order. And with the complexity and with all of the options that customers have when it comes to placing orders for Industrial Ethernet products, making sure that that is as easy and as simple as possible is going to be critical for the solution. So excited for today, excited for everything we have coming. And so with that, I'd like to invite Nazario and Bill up to the screen. Come on and join. And then online we have Frank Moritz as well. So thank you and welcome on.
Thank you, Lucas.
Yeah. Thank you, Lucas.
Yeah.
Well, hello, everyone. And we have the honor of kicking things off with our first panel discussion. Again, this is all about simplifying installation and creating that seamless user experience, right? It's a mouthful, and certainly one that we've been talking about for years. But it's one of those discussions that we need to continue to keep having. Before we get things started, just want to take this opportunity to have our esteemed panelists introduce themselves a little bit, give a little bit background information as far as what you guys do and how long you've been within the industry.
Sounds good, Nazario. Well, thank you for having me again for the second year for the Industrial Ethernet Week. So my name is Bill Martin. I'm a business unit manager for Rockwell Automation's supply of power products. I always say automation starts with us. We provide all the power for automation products. And so I've been with the industry for about 31 years.
Great. Frank?
My name is Frank Moritz from company SICK. And I'm working in that field of the industrial communication now for more than 20 years. So I started mainly with something which is called IO-Link, and then it goes up to the field buses. And that's what I'm dealing. First of all, I was in the R&D department. Then I was a product manager. And now, let's say, I'm more or less a technology consultant in the area of industrial communication.
Great. And my name is Nazario Biala. industry segment manager for Harding, specifically for the automation market. I've been in the automation sector for, gosh, 15 years of my career. I love it, and Bill and I were talking about it. The thing that really draws me to automation is that you actually physically see your products in action, and that's the cool thing about it. And certainly the thing that we said in terms of all the things that have transpired within the automation sector over the past decade, gosh,
Yeah, decade. That's
lots,
10 years. Yeah, a
lots.
lot of
But it's an
changes.
exciting time to be
Oh, it is.
part of this industry. Um, Yesterday, our esteemed panelists talked about all sorts of different technologies, whether it be digitalization and all the things that encompass digitalization, AI, machine learning, digital twin, and so forth. But let's face it, again, we've all been in this industry for quite some time. And I think we could all agree that our industry is not the fastest when it comes to adopting these so-called game-changing technologies. So the things that also we've always talked about is in order to accelerate market adoption, we need to further simplify things, have that seamless user experience, right? Because if our end users can actually see it in action, that hey, it's not so bad to actually start using these technologies that are supposed to make my life easier, then it becomes easier.
Right.
So, want to kick things off? Got ahead of myself. Just want to remind the virtual audience, if you guys have any questions at any point in time, please feel free to drop them in the chat, and we'll address them accordingly. Now, I want to go back to this. So, talking about simplification, and I'll let you guys take this. What does simplification look to you guys? What do you envision as far as what that simplification looks like to our end users and to you folks?
Make sure you have Frank start.
Frank, you want to start?
First of all, for me, it's who is the end user. So I see different industries, and I have painted out two of them. Like one of them, I call it logistics, which they have this long distance conveyor running down, and the other one, as an example, is let's say electronic assembly and robot applications. So there are really different industries behind the end users. And if I think about what is easy installation for the, let's say, also for the cables and to have a seamless user experience, then it's in general that the connections have to be, let's say, fitted fast and reliable and in a robust way. And additionally to that, I want to say, yes, if we can bring two worlds together. One is the data transmission of such a cable, and the power in one cable. That's really beneficial for these industries. And if I come back to the logistic things, then a main benefit is if a technology is able to run long distances, let's say up to 1,000 meters. And if it comes to the robots, electronic industry, then another benefit is, or another requirement is given that let's say the cables have to be small in size and less in weight. But in general, I want to say, yes, if we come to the installation itself, it should be done very fast without any breaking, let's say, mating phases in the connections. It has to be done tool-free in a very quick and easy way. So that is what I see on the installation challenges for end users.
Yeah, and I'm glad that you brought that up, because as we look at this slide, it really speaks to where our industry is moving to, right? Away from your conventional centralized to decentralized, or even edge computing. To your point, making sure that we have the connection and the data collection as close to the actual process as possible. Yes, it's important to, especially with digitalization and all these data that needs to be collected for AI machine learning, to actually be collected and taken to the cloud. But at the end of the day, you need to make that instantaneous decision.
Right.
You want to speak to that as far as edge computing is concerned?
Yeah, so we're trying to just get more information from these smart devices. In the past, we really never had that luxury to get additional information. It was always more electromechanical, just on-off binary. But now, like for a sensor, for example, I mean, the sensors are becoming intelligent where they can tell you that, hey, my lens is starting to get dirty. Maybe the next maintenance cycle, you should go and clean off my lens.
Yeah.
Whereas we really never had that luxury, 10 years ago. You just had to wait for the sensor to fail, and then you had to go and try to figure it out, which was a lot of costly, unplanned downtime.
Oh my gosh, talking about preventative versus predictive, right?
Yeah,
Yeah,
exactly.
preventative, as we all know, it's all based on schedule. Whereas now, with data analytics, now it actually gives us the intelligence to say, you know what, I'm seeing a pattern here where maybe we need to start looking in that particular part of the conveyor before failure takes place. But I also want to bring up the whole decentralized and edge computing, because from an installation standpoint, we could even look at that labor savings. If you go back to the whole decentralized methodology, you have a home run, right? And that control panel can be
It's a lot of wire.
a lot of wire.
Yeah.
And from a troubleshooting or commissioning standpoint, that also becomes more challenging.
Yeah, I've heard arguments for both sides.
Mhm.
I've had customers where they'll do the home run. They like it from the automation perspective. They can just look at one cabinet in one room.
Yeah.
But it's very costly to do that. So again, to save on installation costs, it's nice to have it more distributed.
Yeah.
But you just have to go and run out to those little different areas to figure out what's going on. But by having more of an intelligent solution, the maintenance person can figure out ahead of time before he runs out to that area to know that, oh, maybe this fuse 2 blew.
Yeah.
I'll just
yeah.
go bring my fuse and just replace it. Whereas in the past, it'd be all reactive. The plant's down, everyone's scrambling, going crazy. But now they can, the system can troubleshoot itself, and then they just send out the maintenance guy to reduce as much unplanned downtime as possible.
And from a material cost standpoint, you also you could potentially have more cost savings too, because taking it back to the whole panel conversation. Let's say we have a conveyor that maybe has over 100 motors. Depending on how that looks, you could have a control panel that could be yay big, because now you have to take into consideration all of these heat solutions, right?
Right.
Whereas if you could take all those different conveyors or those control panels, make them a little bit smaller, be as close to the VFDs as close as possible, or to the motors. And I believe you have a.
Yeah, I can talk about the
Yeah.
panel experience. So what our company is trying to do is just a lot of building a panel. There's a lot of wiring. How can we minimize all that additional control wiring? And as things become more and more smart and intelligent, maybe we can combine a bunch of functionalities into one device.
Mhm.
And so what we found is by networking some products, we can save a lot of control wiring, both the wire itself and the installation time.
Mhm.
In fact, we're working on a single pair Ethernet solution right now where we figure we can save 85% of installation wiring time. But
85%.
yeah, it's crazy, man. You literally just plug it together and it just works. But we can talk a little bit more about that in a little bit. But by eliminating the control wiring, it's great because it helps with maintenance.
Mhm.
Plus, now we can get more information from these devices where instead of having a PLC output card telling a motor to turn on, we can just issue a command to say that, hey, turn on the motor. But then kind of going back to the preventative maintenance, we can say that, oh, this motor has been running for 10,000 hours. You should probably go do your routine maintenance, grease the bearings and, clean out the vents and filters and stuff. But so we never really had that luxury in the past, but by having more smart, intelligent devices, not only can we save on wiring, size, and installation, but now we can be more of a smarter panel, again, where it's more preventative versus reactionary.
Well, it's that pattern recognition, right?
Yeah, exactly.
So that's a great point. So let's talk about AI and ML, machine learning, and all the things that it's supposed to be doing for the different key stakeholders within a plant. Let's talk about AI and ML. What do you guys see? Again, it's a topic that's been talked about, especially this past year. It's increasing in popularity. Where do you see AI and ML going towards a whole simplification and providing that seamless user experience?
You want to start, Frank? Go ahead. From a sensors perspective?
Yeah, well, AI very popular in those days, yes, and well, I see it in the area, let's say, of controlling a machine with artificial intelligence to optimize a machine.
Mhm.
But if we talk about that, the main thing is that everything has to be based on data which are collected mainly by the sensors. So. So the sensors and the let's say the information and the data generated by the sensors enable let's say AI services running on a control level. So things are fitting together, and yes, I'm pretty sure that this will come and extend let's say machine functionality in the near future.
Mm-hmm.
You know, from a Rockwell Automation perspective, we're seriously looking at artificial intelligence.
Mm-hmm.
And kind of go back to the edge computing, right? That was always the problem in the past. All these smart things are spewing out all these data points. How do you control and you know, manage all that information?
Because it could be overwhelming, and then I
Oh,
think
yeah.
that's always the thing that's again hampered the adoption, the acceleration, the adoption of new technologies. Is that people go, yeah, on paper it looks really cool, but gosh,
Yeah.
where do you
They're
start?
afraid of it, right?
Right.
You know, I introduced a product 13 years ago. It had a 750-page user manual.
Mm-hmm.
And when people saw that, they were, you know, blown away. Like, well, no, it's the best product in the world, but don't worry about the user management. It's very
Right.
capable. But the things that you can do with it, and that's kind of where Rockwell's going now, is let's take this information and put it up in the cloud. And that's where the edge computing comes in. We really never had that capability before in a cost-effective manner.
Yeah.
So now we can grab the data from the device, pop it up in the cloud. But now we're taking it to the next level where we're analyzing. Let's just look at motor current, for example.
Mm-hmm.
You know, if a motor is running a conveyor, it should just be consuming so much current continuously. But if all of a sudden we see a trend where the current is starting to rise over time, we can tell you that, the bearings are starting to wear out. You might want to do something about that. Or a pump application, if all of a sudden the reactive energy goes up, it means there's an air bubble in the pump. It's cavitating, and so it's really not pumping the liquid appropriately. So we can let the maintenance guys know to bleed out the line real quick, and then you know, get your process up and running again.
Instantaneous, the ability to make that correction right there, as opposed to maybe, again, going back to the whole preventative maintenance, where you analyze all these historical data.
Right.
Now it's right front and center. But it also speaks to what you gentlemen touched on before. Yes, digitalization is great with all the big data analytics that it's supposed to represent. But that could also be overwhelming, as we stated. And going back to what you said before, is how do our end users determine which data is important to them right there, right now?
You know, from a Rockwell perspective, we're taking that seriously, where you know, each of our smart products always presented information differently. Although, you know, there's 3 different motor control technologies, we're all controlling the same motor. You would think we would present the data in the same manner, but we don't. But that's an area that we're working on now, so that whether it's a variable frequency drive, a soft starter, or a full voltage starter, we're going to present information exactly the same between those different motor control technologies. And that way, it doesn't matter, right? If we're all controlling a pump and the VAR, the reactive energy, starts shooting up, we know there's a cavitation, again, for example, occurring. So you can have one common visualization piece looking at this common data set, no matter what the smart device is.
You stated this one example about motors and looking at the current. Had an opportunity to attend an International Airport Baggage Handling Systems Summit. When was it?
That's a good one. I like that.
January. And one of the speakers talked about again, monitoring the current. It's good to have all of this data, but it's also knowing what the data is, because in the past we typically depended on that operator who's been really been working on that motor for the past 10 years, 5 years. So
Or
they
30.
go off their experience. They go off. Okay, so this doesn't quite sound right.
I
Right?
see that all the time. I think you probably do too, Frank, where I'll go visit with the maintenance staff at a facility. You know, it's the old timer guy who's been there for 30 years. He can literally just walk by a panel and he'll just hear a hum. And he just knows that, oh yeah, a contactor is starting to wear out. He'll go switch that out the next maintenance cycle. But all those guys are retiring, so all that tribal knowledge is
Yeah.
going out the door, and the young kids coming in to fulfill that just don't have that knowledge. And so again, by having these smart devices, we can kind of tell you up front that, oh yeah, you know, this contactor's only good for 1 million operations. You're at 900,000. So let's add a ticket to your maintenance schedule to say that let's swap this out at the
Right.
next maintenance cycle.
And it also takes away the human interpretation, and not, I mean,
Yeah,
not to take that away, right? Because it's huge, but now it takes that guesswork out because it's data driven.
right.
It's data driven. But what this gentleman mentioned too is that yes, you can look at a current and you could have a spike at, say, on a Friday afternoon, 2 p.m. versus, say, something on Thursday morning. But it's looking at that data and knowing the typical pattern, right? One could argue that, well, the data spiked up, or sorry, the current spiked up for that motor on a Friday afternoon because that's usually when you have all sorts of people coming back from you know,
lunch or whatever.
their
Yeah.
trip, and so now you have all these bags that are being processed,
Yeah.
and so the current goes up,
It's more of a demand. Yep.
right? So it's looking at that history and that data. But I want to bring it back to Frank. So if from a field device level and taking it back to the edge computing, IO Link has been one of those products that also affords that ability to connect multiple sensors and collect that immediate data. Where do you see that going, and how does that play with your sensors?
Yes, so the advent of the IO-Link brings this connectivity and the data transmission down to very small sensors, even smallest size of, let's say, 4 millimeter sensors. Before that time, we were not able to get any data out of the sensor, but now with that technology, we are able to do this. And there are also some, let's say, condition monitoring sensors right now in the market running that interface. So bringing up temperatures or vibration or acceleration data from the smallest sensors, let's say, to an upper level analysis software. And additionally to that, what was said before, yes, it's true. With this lot of sensors, we get a lot of data, tons of data, and we have to pick out the right data if we do some analysis on that. And I think it's also very important to see the context of that data. So for me, came in mind if we have a pressure sensor, let's say that like that, and we see a pressure peak. Okay, this is some data. But in the context of a different plant, it can have the conclusion is a different one, or the requirements, or the result is different. How to interpret this peak in this plant or that plant, which is coming back to the topic artificial intelligence. Yes, with that one, we can play the whole game, gathering the data from even the smallest sensors, combine them and interpret them in the right way.
Yeah, yeah.
I don't know, Frank, I don't know if you're seeing this trend too, you know, with some of our IO-Link based devices. You know, it's great. It's just, it's a low cost network.
Yep.
It allows us to get some connectivity and some data back, but I think IO-Link's a little limited with the amount of data that you can bring back. initially, like for a sensor, like a photo eye or something, it was
Yeah.
always just binary. But then as we're starting to get, dirty lenses and stuff, and
Yeah.
maybe operational time, I'm seeing more and more information coming from these simple field-based devices. I think it's almost getting to a point where IO-Link, it's starting to become overloaded with data. So it seems like there should be another network technology to help bring out even more information from these small networks.
And then that goes back to, again, the balance of what's enough and what's
Yeah,
not enough,
right.
right?
Exactly.
And it's an interesting conversation, and it's one of those questions that we're constantly going, okay.
So I know, like, Ethernet's great, right? Since it's
Yeah.
Industrial Ethernet Week. The Ethernet's great. Brings a lot of data, but it's very costly. Your standard 4-pair wire.
Mhm.
Ethernet's just expensive.
Mhm.
So like for a sensor, or even for us, it'd be great. Imagine putting a push button
Yeah.
on a network. I mean, unheard of. Who would pay $400 extra to put a push button on a network? But it's other technologies like IO-Link or even single pair Ethernet is a great enabler for us. Single pair Ethernet's another very low cost network. Ironically, it's Ethernet.
It's Ethernet based, yes.
And so we can actually use the exact same protocol just on a different physical media. So now we can start bringing back maybe more information from these lower cost, smaller devices,
Yeah.
but on a Ethernet network. We don't really need a translator or a gateway. And that's kind of where, if you happen to have a single pair Ethernet to standard Ethernet bridge, or even what's the word I'm looking for? A switch.
Hmm.
It just makes life a lot easier because you're just using the same protocol. You don't have to have a
Well,
protocol.
yeah, I'm glad that you mentioned that, because one of the things that's also, again, going back to automation industry 5 years, 10 years ago, you have all of these different languages, and sometimes they're proprietary, and that's why it's always like, oh gosh, how do I commission this thing? And so there's been talks about, okay, well, what else do we need? About, okay, well, we're talking about edge computing, edge conveyors and whatnot, decentralized, but universal connectivity has also been talked about. Do you guys mind defining first what is universal connectivity and what will that eventually do? So you sort of touched on all the different types of connectors and what we need to do to streamline it. If one of you guys can speak to that.
Sure. From a Rockwell automation perspective, ultimately, we'd love to put everything on some form of Ethernet, whatever that is. And for us, it gives our users the same user experience and connectivity, no matter if it's a variable frequency drive that has a lot of parameters, all the way down to a simple push button, which is on-off. But even though it's just a simple on-off thing, we can still tell you proactively, a push button's only good for 10 million operations.
Yeah.
Again, we can count those and let you know that, hey, you're getting up to 999 whatever operations. You might want to swap this green start button out. But for us, we just want to have the same user experience. And then from a data modeling perspective, we want to have common, we call them tags, but memory addresses or ways that you get the data out. So no matter if it's a push button, a drive, or full voltage starter, or whatever, the data value name is the same. It's common. It's always located in this specific address.
Yeah.
Just so that no matter what you're dealing with, you'll always just use the same data point.
So common. I like that.
Yeah.
I like that, right? Because you're right, as far as common user experience, as opposed to user A, oh gosh, I'm dealing with this. User B is dealing with this. Let's all try to get them in the same page.
Yeah.
We have our first question here, actually, and it's related to single pair Ethernet.
Ooh, that's a good one.
Question is, can single pair Ethernet offer power over Ethernet also?
Yeah. Do you want to answer that one, Frank, or I can?
Yeah. So this is a really good question. So if you talk about power over Ethernet or OE, it's called. So the same mechanism is also built in the single pair Ethernet. So it's called power over data link, or in short term PODL, and it works in a very similar way. Yes, it's possible.
Yeah, even I think for like the 10 base T1L, it's the long single pair Ethernet. It's really meant to replace the old 4 to 20 milliamp signal.
Yeah.
Where traditionally with those it was 2 wires, and it could go a long distance, right? It's just it's an analog signal, so you can only really get one piece of information out of like a flow sensor.
Yeah.
But by implementing single pair Ethernet, specifically the 10 base T1L version of it, you reuse the exact same wire, and all you're doing is just swapping out the communication, the smart device, and then a gateway. And so it provides the power over that same wire
Yeah.
to power your smart devices. But then it also gives you all the Ethernet connectivity where you can still use standard Ethernet IP or Profinet or Modbus TCP. It doesn't matter. It's just it's an IP protocol.
So it speaks
Going over
of
it.
simplification,
Yeah, exactly.
unifying that so-called universal connectivity, whatever that means.
Right.
Yeah.
From us perspective was, we used to have DeviceNet. It was a CAN-based network.
Yeah.
You had to have a separate software package to set that all up. It was a real mess to coordinate all that. And then if you wanted to translate that into to an Ethernet or a gateway somehow, or an edge device, that was another mess to do. But by having some form of Ethernet, again, it's the same protocol. The user experience is the same. It's just to use the standard media today or this future lower cost media in the future.
Well, what's interesting too is that if you look at just even the new talent coming in to the industry, they usually they grew up with industrial Ethernet or Ethernet-based solution, right? Because everything from an office environment is Ethernet-based. And as we talked about, when you look at your traditional automation pyramid, and this has been discussed multiple times, so maybe it's a good summary anyway. When you have your typical communication protocol from office environment to your, say, control level, it's industrial Ethernet usually.
Yep.
But then by the time you get to your field device, it's anyone's guess, right?
Yeah.
That communication protocol could be field bus, Modbus, whatever. And the thing that I think the single pair Ethernet will do for our industry moving forward is that now it's going to make that it's going to extend that industrial Ethernet from the office environment all the way to Frank's field device level.
Yeah.
Where the sensors resides, where the cameras resides and whatnot. You could even take away the gateway that typically makes that translation for all those different languages, right?
Yeah, if you just have a switch, that all really just changes the physical media.
Yeah.
I mean, that's the ideal world. In fact, that's kind of where the automotive industry is going with a car. They want to put your door switch, your little light to turn on the dome light, and low critical stuff, all on Ethernet as well. And for them, inside a car, there's always a lot of protocol converters.
Mm-hmm.
They want to get rid of all of those and just have a simple switch, talk Ethernet to everything, whether it's the engine controller, the simple little door switch on your door, those kind of things. So we're trying to do that in industry as well too. So no matter if it's just a quick little green push button, all the way up to a full voltage drive, it'd be great just to have a simple little media converter. Just plug everything in, it just works. It's the same protocol.
Yeah. Well, so Frank, I want to bring it back to the field device level and see if we could bring back that slide back again. Talk to me a little bit about how what effect that will have for your sensors, and I'm talking specifically about SPE. What does that mean for you folks?
Yeah, so for a typical sensor, it's really beneficial if you can use SPE as an Ethernet interface. If it comes to this miniaturization thing, so before it was mentioned the power over data line issue, which is power combined with the data line on the data lines, and we only need 2 wires for everything. So that is one of the main benefits. You can see here on the slide on the right side, there is a sensor on top with 2 connectors, M12, one for power, one for communication. And if we switch it to the single pair Ethernet, then we have only one, let's say M8 connector, very small, and providing all the functionality we need. We have at that point a 10 base T1L communication together with the power consumption. And with this small connector, which enables also to be built in smaller sensors, like we see here, flow meters or small cameras. Then we are really able to do this unified communication, which I want to say it's an IP-based communication, could also be TCP/IP. And as mentioned also before, the sensor is then part of this IP-based network. No, let's say, routers needed or something like that, only switches. And this opens up also the possibility that we can, let's say, extend the automational pyramid, which we always see, which is always point-to-point communication, right, hierarchically, that we can flat it down and say, yes, now we are, if we have IP-based sensors, it's even possible that one sensor can talk to another sensor, not only through the PLC up and down, but directly. This opens up a new dimension of sharing information.
So peer-to-peer communication.
Yeah.
Yeah.
We're doing something similar.
Yeah.
You know, imagine having a push button talk directly to a contactor to turn a motor on. Unheard of, right? It was always just
Cut the
hardwired.
middleman.
Yeah.
Yeah.
And so if you come to our automation fair next fall, you'll see this actually running in action. But I just wanted to comment too on, you know, I'm actually also starting to see a trend where a lot of manufacturers are starting to go more on machine. I think for them it eases troubleshooting.
Yeah.
So for example, you know, if your downtime is $22,000 a minute, they're trying to get things up and running as fast as possible. And so what they're finding with enclosure-based control solutions, you know, you have to get the arc flash suit on. Have you ever had to wear an arc flash suit?
Oh, no, thank God, no.
They're not fun. They're
I
terrible.
heard it's hot.
They are. I have personal experience. Anywho, you have to put on the suit, open up the panel, try to find out what's going on while your mask's fogging up. So the trend is they just want to have everything open on machine as close as possible to where the motors are, the control system. And you know, we're starting to create more solutions where we're combining more functionality for more on-machine based stuff. So for example, like a power supply. We'll have the power supply, we'll have circuit protection, and also control built into one unit. But because these are all going more on machine, we have to deploy more connectors. So we're actually using your Harding connectors for our power supplies. They're the best in the world.
Thank you very
Yep. But I think you're seeing more and more of that too, not only from a communications perspective, but you're going to see more on-machine connectivity for power or control wiring. It'll be all more field-based.
So let's bring it back to what that means to the user experience. Again, the name of this panel discussion is Seamless User Experience. From a field device, we talked about SPE and how that could provide. You even touched on about potentially making your sensor small, which speaks to the whole miniaturization trend, right? And your on-machine. Let's bring it back to what that means to our end users from an installation and seamless experience standpoint. How does that translate?
Actually, kind of relates to a question that came in. The person was asking, you know, if a push button costs $400 to put on Ethernet, how does that compare with single pair Ethernet?
Yeah, so that is the question. If an Ethernet button costs $400, what about single pair Ethernet?
So it'll be about a tenth of that.
Okay.
Yeah, single pair Ethernet is very, very cost effective, very similar to IO-Link, but again, you get the higher bandwidth of information. To keep it seamless and simplified, again, it's we can a push button will just look like a motor starter or a drive in the automation ecosystem, and as long as it'll all eventually have common data values, common naming conventions for all the data. So that way, again, the edge computer can come and just grab this common data point, no matter what type of device it is, and then can analyze it up in the cloud in a very seamless, efficient process.
And you also talked about the beginning where you said 85% savings.
Cost reduction,
Yeah,
yeah.
if you can talk a little bit more about that.
Sure. So a traditional full voltage starter, you need about 11 pieces of wire
Hmm.
to make it work. You have to wire up the motor protection circuit breaker, the contactor, and the overload relay, and all the
It's
auxes.
expensive.
Right? And then you had to bring it back to an input-output card of a programmable logic controller.
Hmm.
And then the time it takes just to do all that. And of course, somebody's not going to wire it in perfectly all the time, so wires might pop out or whatever. So our goal was, let's just get rid of all the control wiring, those 11 pieces of wire, and replace it with a simple single pair Ethernet cable.
Hmm.
And that way it just, it's all pre-connected. It's communicating using an Ethernet protocol, in our case, Ethernet IP. And then kind of what Frank alluded to earlier, a green push button can just talk directly to it.
That's so mind-boggling. 85%. Holy cow.
Yeah, it's, have you ever had to wire a panel? Had the
Oh, yeah.
luxury
Oh,
of
yeah.
wiring one? It's a lot of work, right?
Yeah.
And in fact, we actually did a study. We hired a company to wire up 10 motor starters with push buttons and pilot lights.
Hmm.
And we did the time-lapse video. And it took them about a day to wire that up, if not a day and a half, using this other new technology. They literally did it in an hour and a half. It was amazing. Yeah. By the time you don't have to strip wire, crimp it, tighten it in, literally just putting on a ribbon cable to connect it all together. It really saves a lot of time. And that's
It
just
speaks to the whole total cost of ownership. Right?
exactly.
Because it's not just material cost, but as you said, it's the installation process,
Yeah.
it's the commissioning process, and at some point, maybe maintenance,
Correct.
troubleshooting.
So not only are we simplifying the panel with less wires, these devices are more intelligent so that they're kind of predictive themselves. They can tell you when they're going to fail proactively.
Yeah.
And again, in a common way, so that you literally just kind of connect these things together. And if you had your system set up, it just knows what to go read automatically. And it'll just tell the maintenance guy that, oh yeah, hey, next maintenance cycle, why don't you swap out this contactor?
How about you, Frank? You want to expand on that as far as what it means for your
Yes.
end users?
So very important is the cost for the installation, as mentioned before, and that's right. So if we can replace, let's say, 6 or 8 wires or different wires for different signals by one 2-wire interface, that's really beneficial, not only in material costs, but also in installation costs. Just plug these two together and it works. Yeah? And that cuts down really the costs setting up let's say a machine. Yeah, it's not only let's say the button itself or the sensor itself, but the connecting costs of the effort for connecting it. That's one of the main benefits, which is really cut down by using single pair Ethernet. And if it comes on top that the protocol which is running on that Ethernet is also unified or unique, that's the best of the story at the end. So we don't need any, let's say, translations for the data. Then we get a real seamless experience, user experience from hardware fitting the sensors to the switches, to the data flow, to the interpretation of the data.
So Nazario, there's a question that
There is a question. We have another question.
our users want, or our viewers want to know. So when is this single pair Ethernet technology starting to come out? So from a Rockwell automation perspective, we want to give this gift to the world around Christmas time.
Christmas time. Okay.
Here, our world gift.
We'll take it.
Yeah, right. So it's coming sooner, right? I know the last couple of years we've been talking a lot about single pair Ethernet in general. And granted, the IEEE specification is relatively new. I mean, it was just ratified a couple of years ago. Yeah, we're seriously moving forward with it, and we'll be releasing some of the first products here around Christmas time.
But that's great news because, like you said, we've been talking about SPE for quite some time, and defining all the different ecosystem, all the different components that play into it. So it's great to hear that we're going to finally start seeing out there.
I think so too.
Being used in real use cases, because it goes back to the challenge that our industry has had over our history of, yes, we recognize what all these new game-changing technologies can do for us from a benefit standpoint and how it can make our life easier, but we sort of have that trepidation. And to actually see it and working firsthand, I think that's the starting point of hopefully opening up the gateway for us in terms of, hey, it's here and it's here to stay.
Yep, definitely.
So we have 3 minutes left. I want to go back to, well, we still have this 3 minutes left. I want to go back to, I believe it was either Frank or you that talked about the peer-to-peer communications.
We both did. Yep.
Yeah. And I think there's something to be had there, and is something to be said there in terms of going back to the whole simplifying the whole user experience. Because if you go back to what it was before, you may have an example that I usually like to make is you have a conveyor line where you have a gating sensor. You have a photo eye that says, hey, I sense the box coming in. It sends that data or that data to PLC, say, hey, I see it. Now tell vision camera to be on the lookout for this box and to inspect to make sure that the actual label, the proper label is applied to it. Now, with that peer-to-peer communication, that gate sensor can immediately talk to that vision camera, right?
Exactly. You know, my other favorite example is a wastewater treatment facility. It's filling up a tank full of bad water, dirty water, gray water. Maybe you have a proximity sensor on there to see what's the tank level going to be, and what if the control system goes down? I mean, that tank's still filling up with sewage. And so we wanted to make sure we could handle that use case. So if the control system goes down, and this is the original reason why they did hardwired control solutions, is that, all right, control system's gone, we can still flip on the switch to keep that pump running and get that sewage out of the tank. So by offering peer-to-peer communications, it solves that issue. So that we get rid of the extra wiring, but now we can just
easier installation.
Yeah, right. And now we can just talk directly to the motor starter. And keep that thing running, even if the control system were to go away.
Holy cow! It looks like we're running out of time here.
Wow.
It looks like we're getting the hook. So thank you everyone for joining. I want to thank our esteemed panelists for sharing their insight as to where our industry is moving. So again, thank you to both of you. And we're going to take a quick break, but I encourage you to come back for our next session, which is how field-installable products change the game.
That
So,
sounds
come
pretty
back.
cool, Nazario. I can't wait to see that one.
Yeah. Well, you got front and center.
Excellent.
Thank you, everyone.
Welcome back, everyone, to our second session for today. And we heard in the first session about single-pair Ethernet, and we heard about industrial Ethernet. So we'll take a quick dive into the products that are used in industrial Ethernet. My name is Wissam Yacoub, and I'm the product manager for electronic products with Harding. And in the next 10 minutes, we will be talking about some of the products that are used in industrial Ethernet. So let's start with a quick overview of the products. I will talk in the next 10 minutes about products that are used inside the cabinet. And then I have Brandon, who's another product manager, will talk about products outside cabinet. And we also have Maria Walker, one of our application engineer, will talk about panel feed-through and Ethernet switches. So speaking of products that are used inside the cabinet, of course, the standard product in the market now is RJ45 plug, and Harding offers an industrial RJ45 grade that is rated for Cat 6A specifications or requirements, up to 10 gigabyte per second in multiple or in different orientations, straight or angled. The other products that I wanted to cover quickly is called RJ45 Vario Boot, and this product is an overmolded patch cord. with angled connector that introduces very high flexibility of the angle and orientation of that connector. And with that flexibility, first of all, it helps for a best fit inside the cabinet, and it also, no matter what at the end of the day, no matter what the route of the cable needs to be, that cable can go with you in any direction with no risk of losing data or signal. There's something also called RJ Industrial Multi-Feature, and we call it multi-feature because it's linked to another product we'll talk about in a second called Pre-Link. The RJ45 multi-feature or industrial multi-feature introduces is a higher assembly time or faster assembly time in the field and reduces the assembly time by about 25%. And it's a tool-free field assembly, and we'll talk about that in details in a few seconds. So this is the Pre-Link product that I mentioned, and let's talk about this slide first. So Pre-Link is like a cube where you connect all 8 or 4 pair of wires into that cube. And if you ever have to assemble an RJ45 connector in the field, you know how not user-friendly that assembly is. With that cube, it's very easy. It takes about 20 seconds to assemble that cube into the 8 wires. So you assemble all 8 wires into that cube. You crimp. There's a special tool for it, and you crimp it, and there you have your Pre-Link with the 8 wire. That Pre-Link could be now you can use that Pre-Link cube in the back of the RJ45 connector, and now you have the RJ45. It's a very fast termination method in the field that's very helpful. The other advantage of this Pre-Link product is that you can use it with multiple of other products, where after you have that cube, stick the cube in the back of the connector, and you can have your Silker metric connector, fiber optics, RJ45, and some other connections that we'll talk about, or connectors that we'll talk about in a second. The next product is IX Industrial, and we heard this morning a lot about IX Industrial, and this is the IX Industrial connector. And if you can see on the bottom right side of the screen here, the difference in size between the standard RJ45 and the IX Industrial connector. And I actually have that PCB board with me here that has a standard RJ45 on one side and the IX Industrial on the other side, and you can see the difference in size. It's a lot smaller. It allows you for multiple connectors in the same space as compared to the standard RJ45. This IX Industrial connector is 360 shielded. It's an IP20, and there's another version of that called push-pull we'll hear about in the next few minutes that is also IP65 rated. Now let's talk about single pair Ethernet. We heard about the single pair Ethernet in the morning session, and we also had a confirmation that yes, that single pair Ethernet can also transmit power, not just data. So a standard or industrial Ethernet connectors use 4 pair of wires, so 8 cables or 8 wires to transmit up to 10 gigabyte per second. Standard, the single pair Ethernet uses 1 pair of wires, so that's 25% of the copper used compared to this standard RJ45 or industrial Ethernet. So let's look at quickly at the speeds of the single pair Ethernet. You can use single pair Ethernet for speeds up to 10 megabyte per second. You can use that to up to 1 kilometer of transmitting data, 1,000 1000 meter. For 100 megabyte per second, you can use it up to 40 meter, and for 1 gigabyte per second, you can use it up to 15 meter. And Harding is also working on developing a 10 gigabyte per second connector for single pair Ethernet that's coming up this year. So let's talk about the advantage of the single pair Ethernet. In a legacy communication, we would have the IT level or the cloud using standard Ethernet, and then you have the control level or the panels using industrial Ethernet, and then you have the equipment in the field using a field bus system. Those are three different communication systems that are very hard to talk to each other because they speak different protocols, different languages. With single pair Ethernet, as we heard from Nazario this morning about how this will allow a very smooth flow of data from the cloud, from the IT level, all the way down to the equipment, and getting this data back for analysis or diagnostics of any issues or any problems in the field. Now let's touch base on the application of single pair Ethernet. Single pair Ethernet could be used in data centers. Remember, it's a very smaller, it's miniaturized compared to RJ45 or standard Ethernet. So if you have a panel that you need to put like multiple 50 or 100 connectors in the same panel, it's a much smaller in size. And we have a question. How many times can you change out the end termination prior to seeing issues? For single pair Ethernet, I do not have that number off the top of my head, but I can definitely get back to the person asking that question. I don't have that number right now. So back to the applications in data centers, in control or PLC and in the field, and also in WAP systems, in passenger cameras, in in-flight entertainment systems. There's a lot of different applications where single pair Ethernet connectors could be utilized. Speaking of applications, the single pair Ethernet is just the connector that can be inserted into different connectors to give you the flexibility to use any metric circular connectors using the same technology. And with that, speaking of metric circular connectors, I will leave this to Brandon to talk more about the different components.
Thank you, Wissam. Good morning. I'm Brandon Caesar, product manager with our Harding Customized Solutions group. And it's great to be with you all this morning. Wissam just gave us a walkthrough of our inside the cabinet Ethernet solutions, and I would like to take you through some of the outside the cabinet solutions. So we'll start with Harding's wide portfolio of metric circular solutions. So up on the screen, or on the slide here, you can see for our fast Ethernet, you can see the M8 decoded and M12 decoded interfaces. And then for our gig speed Ethernet, we offer M12 X-coded interface as well. What's not shown here, Wissam just walked us through the T1 or SPE technology. We have an interface in the M12 form factor with the single pair Ethernet as well. And then the last one that you see on the screen here is the M12 Y-coded, which is a hybrid interface where you can have fast Ethernet and power in the same interface for a space savings. All of these interfaces, the screw locking style, are standardized per IEC standards. So that maximizes your backwards compatibility and intermatability in your application. And they are available in a wide range of termination styles. So Wissam just walked through the IDC termination style. We have crimp and screw terminations available as well. And many of these interfaces work with the pre-link cube that was just shown as well. One thing to note at the bottom of the slide there, you can see the animation. We also offer these M12 interfaces with a push-pull type locking mechanism, which eliminates the need for a torquing tool. And it really makes insertion and removal of the connector a lot easier. You get an audible click to let you know that the connector's been mated properly. And then removing is simple as just pulling back on the housing and taking the connector off. So this is a big space savings. You can actually put more connectors next to each other and maximize your space there. So moving on from metric circular, we just talked about RJ45. A lot of legacy applications and even new devices are still using RJ45 interfaces. The issue is that with outside the cabinet, RJ45 wasn't really designed for harsher environments, right? So Harding has our RJ45 interface in our push-pull housing, which is outdoor rated, IP65, 67 rated, depending on the housing, and is available in two different housings, the V4 and the V14, as you can see there. One is slightly larger. But the benefit to this, similar to the M12 push-pull, is the ease of application, right? So you still have that audible click when connecting this housing to let you know that it's properly mated, and then removing is just simple as pulling back on the housing and taking that out. Again, it's outdoor rated, shock and vibration proof, and it's available in overmolded and non-overmolded cables as well. We also have inserts or you can use the pre-link cube with this housing as well. So another variation of the push-pull is the push-pull mini IX push-pull. So we just talked about the space savings that you can achieve with the IX and the benefits of that, but we now have that same technology in a miniaturized housing with the push-pull technology. So again, maximizing your space, you can apply more of these in an outdoor area with the IP65, 67 rating and take advantage of the push-pull technology here. And then lastly, again, with push-pull, the fiber optics portfolio that Harding offers. So fiber optics, the benefits of using something like this over a copper connection is you can take advantage of longer runs of this cable. Copper cable is usually maxed out about 100 meters, and this can exceed well beyond those lengths. The data rates are much higher, almost unlimited data rates. And then you remove the EMI that you currently see with copper connections. These fiber assemblies are available in both single and multi-mode versions. And then again, with the push-pull housing, they are IP65, 67 rated. And again, you get the benefits of just the ease of application with the audible click and easy removal of these. Again, these are available in overmolded cable assemblies and just make installation much easier for your outdoor application. So that covers all of the outdoor solutions that I wanted to review with you. And at this point, I'll turn it over to Maria so she can cover the panel feed-through solutions. Thank you.
Thank you, Brandon. Good morning. My name is Maria Walker, and I'm one of 6 field application engineers that support Canada and US. Okay, let's continue. So to recap, we spoke about solutions that we offer for inside of a panel where sealing may not be as prevalent, while Brandon covered the same solutions for outside of a panel using push-pull. Now let me walk you through on how we can take those same solutions for panel feed-through. Oh, I didn't have my slides. So as you previously heard, Brandon mentioned using an RJ45 to an M12 push-pull for outside of a cabinet. Well, for a panel feed-through, we offer an RJ45 to M12 coupler. The RJ45 is available in M12 D code, X code, and is available in a straight and angled orientation. The coupler is all one unit, very easy to install. You simply remove the lock nut from the M12, feed the M12 through the panel cutout, and lock the nut back on. To accompany our coupler, for standalone circular connectors, we offer M12 cables with flying leads. The M12 is available in a D, X, and Y code. These are available in various lengths as well. And for an application where you have, say, two plugs that you just need two plugs that are finished and you just need to plug in, we offer a gender changer in an M12, which makes a nice extension. Keep in mind that the M12 gender changer is available in a D code to D code, X to X code, and a D to X code. So we have 3 different coding combinations. Next on the list, we have our Hardport series. Hardport was specifically designed to use for interface access ports. Hardport's compact and rugged and offers a sleek design. The Hardport can be easily mounted on an interface with an RJ to RJ45 pass-through, or we have patch cable in various lengths as well. Along with that, we offer an RJ45 push-pull as a coupler ready for Cat 6A and 10 gigabits. If, however, locky levers are preferred, we offer a HAN 3A with a built-in RJ45. Again, is an all our Ethernet question. All our Ethernet offerings, we offer, these are completely 360-degree shielded. For a small form factor of approximately 70% less than the traditional RJ45, we offer the IX series. IX is small, but it's quite robust and can certainly withstand high shock and vibration applications. I'd like to point out, though, that for the IX, we offer 2 versions. We offer Type A for data and Type B for signal. But specific for a panel feed-through for an IX, we have a MIDI push-pull with a bulkhead and 2 integrated IX connections. Very easy to install. The bulkhead allows the bulkhead pushes through the IX through a panel, and then you have a gender changer as well. Next on the list, we have our HAN modular series. This is actually one of my favorites to work with. HAN modular is an extension of the HAN series and well known for its robust rectangular design used in industrial applications. The nice thing about the HAN modular, it's completely customizable, and you're able to combine power, data, signal, pneumatics, as well as fiber all in one connection. But specific for a panel feed-through, the modules that we're offering are the megabit and the gigabit modules available for Cat 6 at 8.2. Along with the modules, we also have an RJ45 pass-through, RJ45 gender changer, and are available with patch cables in many lengths as well. From all the products you've seen today, last but not least, we offer our unmanaged Ethernet switches. We offer a pretty extensive portfolio of switches that are ready for plug and play. These switches are available on all the interfaces you've seen today, such as RJ45, M12, IX, as well as single pair Ethernet, which, by the way, you'll hear more in depth in tomorrow's presentation. Our fast Ethernet and full gigabit offer 3 to 16 ports and are also integrated with and without power over Ethernet. Our switches are compact and robust, and offer a slim or flat design and can be mounted on a bracket or a traditional DIN rail as used many years back. In a nutshell, this concludes our solutions for today for Ethernet. Oh, I think we have a couple questions. What about the M8 coupler that supports single pair Ethernet? I'm actually not sure. I'm not sure if Brandon can help me with that one. We can certainly get back to you. I'm not sure about that offering.
Just M12.
Just oh, okay. Someone on the panel just said that M12 is the only one available for SPE. Can we combine 120 volts and RJ for Ethernet in the same connector? We have been using 3 and separating power. Yes, we can certainly combine that. I can help you through that if you reach us at techsupportus@harding.com. Was that the same question? I think so. Okay. Well, thank you for dedicating your time and attention with us today. I hope you're walking away with a bit more knowledge, and we've piqued your interest in expanding your portfolio with us further. Next, I'll reintroduce Wissam to the panel to talk about digital tools.
All right, welcome back, everyone, again. In this last session for today, we will be talking about digital tools. We'll introduce some of Harding's digital tools for PCB connectors and systems and designs. I have with me on the line Max. Max, can you introduce yourself, please?
Yeah, good morning also from my side. I hope you all enjoyed the sessions. I'm Maximilian von Bern. I'm the Digital Transformation Manager for the GBU, and regarding this, I'm responsible for the digital services and tool for PCB connectors and field as digital connectors.
So Max will talk to us or introduce to us some of the digital tools for PCB connectors. So what topics are we going to talk about? What kind of tools we will talk about today, Max?
Yeah, so we will bring up 3 big topics today. So first of all, our configurator for our modular PCB connector series, HAR Modular. The second one is our engineering data for PCB connectors. And the third one is our product data manager. So Wissam, I would say let's start with the HAR Modular configurator. But for this, it would be great if you can have us or give us some insight. What is so special about the HAR Modular series?
So for HAR Modular, as we heard from Maria a few minutes ago, the HAR Modular is a very highly customizable configuration where you can mix and match different connectors, signal, power, or data connectors in one configurator.
Yes, so that's right. So there you can mix a lot of different modules for signal, data, and power transmission. And regarding this, there are more than 1 billion possibilities in this series. The main question is now how you, as a customer, can find your specific solution quick and easy. And for this, we developed our HAR Modular configurator.
Okay, let's get started. So where do we find this configurator, Max?
So yeah, our starting point is, of course, our harding.com. And there we find our configurator in our eShop. And you find it with a click on the eShop. And at the next step, you find it then down there in the menu on the right-hand side. This is the HAR Modular configurator. I think now the video gets a little bit too fast, but this is the best description.
Okay.
Now we see it here. Yes, there on the right-hand side, you can see it. And there we have then the first starting point.
All right, so this is the starting point. What is the starting point? How do we start with this configurator?
Yeah, you see it already here. This is the start of each configuration, and we now want to have a new configuration. If you are for the first time in the configurator, you have the possibility to watch how-to video. So you learn how to configure this solution, and then, like we just saw, you have the possibility to start with a straight or angled male version or a straight female version. Now we decided here to go on with a angled male version.
Okay, so let's start with that. How do I find the right product for, or the right module for my application?
Yeah, right. So this is the starting point. You see there are already two modules on the left and on the right side preset. These are our P modules. So this is to have a good connection between the male and the female side, and also the connection to the PCB. And then we have this green transparent module in the middle, and here we can select our individual model for our application. We now want to have a data module. We can find this with our selector on top of this, and we have here two different possibilities. I now go with the bigger one, and then we can add with a button add modules, each module one by one. We go on with a 10 current version of a contact, and have here a solder and crimp version. And there we take the solder version and now we can also add our last module, and we can do this also very easy by going through the list. And we now then select here the H3 module. After this, we have finished our configuration, and we can have a look on it.
So you said we finished the configurator. What if I wanted to make a change? Is that easy, or do I have to start from the beginning?
Yes, good question, Wisam. So we not have, if I maybe say during the configuration process, okay, I want to change a model, the place B to and have another module. I not have now to go back and delete every model step by step. I can easily do this with our move module function, like we just saw, and there I can do it very easy via the drag and drop function. So this is very quick and easy, and yeah. If we now want to go on to configure also the female side, it is also this is very easy.
So let's do that. Let's go and configure the female side of the connector.
Yes. Like you see here now, there is on place C already a preset module. This is the H3 module. The configurator, I would say, is intelligent. And if there is only one mating partner at the position, then it is already preset, so you not have to select this by your own. And now we're going on with the configuration and place on all different open spots the left modules. And after this, we really finished our both sides of the connection.
So now I finished the configuration. Can I save that, and how?
Yes, absolutely. So for collaboration, we find it's very important that we have a save function. You see this here. For example, I now going with the IEW Harting US 2024. And after I save a configuration, I also, and of course, have the possibility to immediately load a configuration out of the configurator. Moreover, you see here the configuration ID, and you will, and additional to this, you also will receive an email to your specific account with this information and with the configuration ID. And after this, you can load it again into the configurator. Necessary for this is my Harting account. This one is free, and I really can recommend to you to register. If you not have yet, it is, yeah, like I said, free, only a few clicks, and then you have access to a lot of function and engineering data on our website.
So you said after I save it, I get an email. What exactly in that email? What kind of information do I receive in that email?
Yeah. So at the one point, I said that you get an configuration ID, but of course, we also had the possibility to download there a huge package of engineering data. And you find this at the solution page on the bottom of each page. And there, if we go there, you have the possibility to download a data sheet, a type sheet, a pre-assembled type sheet, 3D data. And what I really can recommend to you is the pre-assembled type sheet. So for your individual configuration, you will receive a type sheet with the footprint information for this configurator. And all of this also coming in an email. You just received here this information, and then you will receive an email with a zip file. And this is then the next step where we go through. You see this here. You can download the zip file very easy. And then there are the different options I just selected available. And like we see then on the next picture, that there is a type sheet, and there you can really see on the right hand side the footprint of our connector. So this is also a very nice feature we want to achieve with this, that you can start with your design really immediately.
Nice. So now I finished my configuration, got the information I need. Can I order a sample off of that configurator?
Yes. Also, sample service is for us very important. Right next to the download button of the data, we have here the sample service. You can put in very easy your personal information, and after this you can submit it. Also, you can add there, do I need an assembly add or not? If you never had a HAR modular configurator before, we send this assembly add also for free to you, and then you will receive single modules for this sample.
So for ordering, can I order the configurations all assembled, or do I have to assemble them? Do I order them separate components and assemble them?
Yeah. So this really depends on the length of the connector. So as more modules you use, as bigger your configuration is, this is then depending the MOQ. So for this configurator, it's 144, and for this 144 or more connectors, you will receive a pre-assembled version. Otherwise, you get single modules, and you have to assemble them by your own.
So what's next for this digital tool?
Yeah, so for this digital tool, and also for the series, it is next to bring up a cable configurator and a cable connector. And this we want also to add this to our configurator. That is all available in one tool.
So let's summarize it. What are the benefits and advantage of this tool?
Yeah, so the main advantages are that we have this very quick and easy individual solution. So you can really put this all together very, very easy. And after this, you received a pre-assembled, you received a type sheet of this pre-assembled version. And moreover, we also have a sample service in place so that you can start your design in very fast. So we have always the aim on your side to save time and minimize errors. So by give you a whole data package and a sample during the stage.
Okay, that's a very nice tool. Now let's move on to the next tool. You said something about engineering data.
Yes. So our next tool is, or our next topic are the engineering data, and in this context, we are offering a high amount of engineering data for our PCB connectors, and also this is we can find in our eShop, but there we will go in just a second.
So this engineering data is only for PCB connectors. What else? Is it also available for other connectors?
Yeah, so we are offering this this service for all our PCB connectors. For other components, there we, for example, for installation technology, we are offering also special engineering data there. And for the PCB connectors, we are offering, for the whole portfolio, this kind of engineering service. We will just have a look on it.
Okay, so let's get started on this engineering data tool.
Yeah, the same thing like for the HAR modular configurator, our starting point is the eShop, and there we find, for example, a T1 industrial jack, and where we can now find this data exactly. So in the download area and there in the category of engineering data, and by clicking on this little icon, there will come up a pop-up just very short, yeah.
Before we move to the next point, that I just wanted to mention that the T1 industrial connector, that is the single pair Ethernet connector that we talked about or referred to in the morning. Okay, so when I download this data from the engineering data, I know our customers use different softwares and for their designs. Is that all available in one package, or is the data only available for one type of software or tool?
Yeah, so when we go now through this download, we have here or find here symbol, ECAD data, and also the 3D data, and we can, I would say, play here a little bit with the data. We can only have a look on the device or together with the PCB. And after downloading this data, also in this case, we will receive a zip file, and in this zip file, there is then a high amount of different data for different tools available. So more of it, more than 20 of the most common software design tools, and our customers can then use the tool or the data for the tool they need.
Okay, so if some of our customers work with distributors, is this same tool available on the distribution websites?
Yeah, exactly. So this is another very nice function of this service. So it is not only available on our site, it is also available on some selected distribution partners. And you can be sure we are all having there the same database. So if you're going to our website or to the distribution website, you will receive the same information of data because, there are the same. It is the same database. We're working together with a third party company. Yeah.
So let's quickly touch base on the benefits of having this engineering data.
Yeah. So again, the main our main goal is that you save time and prevent errors during the design stage, and you can really, depending on the complexity of the component, 45 minutes up to couple of hours, and this is also our main goal. And then you receive symbol, footprint, and 3D data. You have the choice between a lot of different ECAD data formats, and you can integrate this data then immediately to your database, and there's a lot of data available across our eShop and also across the supply component search network and also our distribution partners.
Okay, so let's move to the last tool, product data managers. Some of our customers are interested not just in engineering data, but also data sheets, type sheets. How do we find this kind of information?
Yeah, so on the one hand, we of course have this special type of engineering data we are offering to our customers, but on the other hand, customers are interested in data sheet, type sheet, 3D data, and also for this topic we have a tool in place, and we can find or we just go through this in just a minute.
Okay, let's do that. let's go through that tool.
Yes, you can find this tool again in our eShop, but in this case is the area service and then product data manager the right starting point. And here you have an overview about our product data manager. So there are two functions. First of all, there is a download package function. So regarding all the data sheets, type sheets, 3D data, but we are going through this also in a minute. And on the other hand, you can download a specific Excel sheet with technical data. But we first of all now concentrate on the left download packages, and there you can download all information for 50 data in only one step.
And importing this data is available for what kind of format?
Yeah, I just imported here now the data. This is possible via our wish list or from the basket or with an Excel sheet or only just copy and paste. And then you see this here on the right hand side, all products we implemented here. And now we can go, or we have another function here. If you put in a wrong part number, it is not possible to put this one in the product data manager. And now we can go to select the product data, and here we can have the choice between a product image. Our multicad download is in place for a lot of 2D data and 3D data, and moreover, we have the possibility to download type sheets or the asset administration shell. I would like now here to take the pictures, the type sheets, and also the 3D files.
Okay, so those are the types of data that I can download.
Yes. Yeah. So after I selected the information I need, I again will receive here an email. I also need my Harting account for this, and then when I go now to the email, I have again a zip file, and there I can download or have access to all the different informations I just clicked on.
So we imported a bunch of part numbers from Excel spreadsheet. Can we also do that for a single part number and get a single technical data?
Yes. So we just here have the view for the email, and also on another page we can see the file, how this one can look like, and then we can go on with the technical data. And yes, this is also possible. Now we are focused here on the right server, or on the service on the right side, and we can import Excel easily via drag and drop. And after implementing this service, we can select what kind of information we need. And in this case, of course, we're talking about Ethernet. We want to have a look then on the data rate, for example. And here, after I selected the different informations I'm interested in, I can go to the download button again, and after this I will receive again an email with a zip file, and with this there is an individual Excel available.
So let's talk about the advantages of this tool, of this service.
So again, it is time saving. During the engineering process, you have different, or you can import. There are 50 products in with only one step, and after this, you will receive a lot of data for your engineering process, and you really, depending on how many products you implemented to the product data manager, you save a lot amount of time, and there is an exponential growth if you put more products in this product data manager.
All right, thank you so much. That was very helpful. At the end, we'd just like to thank everyone. Thank you so much for joining us today and for taking time out of your busy day to join us with this session for day 2. During the morning session, we've seen a lot of questions specifically about single-pair Ethernet technology. So tomorrow, we will have the president of ODVA joining us to discuss research that is recently commissioned on SPE readiness. And we'll also talk about emerging innovations and emerging technologies. And we would love to see you again tomorrow. Thank you and have a great day.